In this video, we're going to work through Packet Tracer 1.1.4.5, configuring and verifying a small network. This is from the Routing and Switching Essentials course by Cisco, version 6. And we'll be covering each step of the instructions and discuss in some detail what each step does and why we're doing it. At the end of the video, we should be able to ping between PC1 and PC2 and connect to the switches remotely for management. So the first thing we have to do is set up the basic information for the router. This is going to include hostname, banner, passwords, and interfaces. So we're going to click on RTA, and that brings up the box for that. Click on the CLI tab, and I'm going to stretch my window out to match up the lines. And you see now the host name for this is router. This is a router that is in completely default configuration. Nothing has been changed, and so we have to go through each step of the way. So I'm going to do enable and then config T, and the command for this is just host name and then the name. So RTA, and you can see that it changes from router at the prompt to RTA, so that lets us know we did that correctly. Then for the banner, this is the message that's going to pop up like right here by the return to get started. It's going to pop up a message that says something. So it's banner MOTD, and then just put your message in after that. You'll see that I have quotation marks to begin and end my message, so everything between those quotation marks is going to be what is included in that banner. This is a best practice to name our equipment so that when we connect to it, we know which device we're on. Normally you'll be connecting through the network. It's going to be located somewhere remotely in a network closet, and you will not often be going to the equipment and plugging the console cable in to connect to it. So when you're accessing it remotely, it's good to have a name for each device so that you can verify as you're doing configuration that you're on the right thing. And then the banner is important because there is some legal precedent that either not having a banner at all, or if you put a sarcastic message on this, that could be seen as an invitation to try to attack your network. We need to add passwords for this router, one for console and VTY lines, and one for the enable secret. So let's do the enable secret first. So enable secret, and this is supposed to be class. And this is the password that we get when we go from the regular user mode into user exec. Oh no, I'm sorry. From user exec mode to privileged exec mode, we type in class. Because we put in the secret, that means that it is going to be encrypted in our running config. Now we need to add the password for the lines. So we'll start with the console line, so line con 0. And we just use the command password, and this is going to be Cisco. And then we tell it to use that password for login. We need to do the same thing for the virtual line, so VTY 05. And this is going to set it for all of the lines 0 through 5. And we use the same commands after that. Password Cisco and login. So let's see what that does now. So if I exit, out, and it's now trying to look up end for my DNS. So we'll just talk for a second while it does this. So if I exit out of this command entirely, then you can see that I go back to my console is available, press return to get started. When I hit return, you'll see my banner, which is authorized access only. And then I need to put in the password I just used for the line right here where it's asking for password. So I'll just type in Cisco. And now I get the user exec prompt. I need to move on to the enable mode, so I'm going to do enable. And it's going to ask me for another password. This one is class. And now I'm at the privileged exec password again, or prompt again. All right, so the next thing is configuring the interfaces. On each interface, we need to do 4 steps. 1, we're going to enter the interface config mode. 2, give it an IP address and a subnet mask. 3, turn the interface on with the no shutdown command. And then 4, we're going to add a description of the interface. So go back to config mode, and then on the interface, we're going to start with gig 00. This is the first line in the addressing table. It's also, you'll see the one that's headed to PC1. So interface gig 00, and then IP address is 10.10.10.1 and subnet mask 255.255.255.0. Now we give it the no shutdown command. So I just type in no shut. You'll see that as soon as I hit enter on that, I get a status message in my console. Also, the link lights are changing over here. And then we need to add a description. So we just use the description command, and we are going to call this link to SW1. And we're going to do the same thing on the other interface. So interface gig 01. IP address is 10.10.20.1. But before we do that, I want to show you what happens. Remember, routers are expected to have each interface be on a separate network. So if I put this second interface on the same network as we've been using, so let's say 10.10.10.5, 255.255.255.0, I'll get an error message here that says, oh, this interface that you're trying to configure overlaps with one I've already got, and it will not allow me to use that. So that's good to know, troubleshooting there, and if you run into that message, that's why, because you've got something already configured. So I'm going to do 20.1, and it will like me this time. I'm going to do a no shut, and description is link to SW2. Again, these descriptions are a little bit like the host names in that there's something that can be used to help you understand where that next hop is from that interface. It's not required, although in this packet tracer we're getting a change in our completion percentage every time we add that description, because it is checking for that. But it is a very helpful thing. It will really help you to be able to visualize your network and know what you're looking for when you're doing troubleshooting down the road. So I believe that's everything for part 1, steps 1 and 2, or I'm sorry, part 1, step 1, except for saving the configuration. So I'm going to exit out of this, and from this prompt I can just do a copy run start, and it will ask me, do I want to save the startup config? Yes. Alright, so now let's move to PC1 and PC2 and set those interfaces up, as that is the next step. So when I click on it, it brings up this. I'm going to go to IP configuration and 10.10.10.10, 255.255.255.0, and then the gateway is going to be the address of the router on that interface, or on that link. So 10.10.10.1. And that's it for that one. Let's kind of drag this over. And then let's do PC2. Again, desktop IP configuration, 10.20.10.20.10, 255.255.255.0, and the gateway, 10.10.20.1. And that should be all that we need for those. We can test this real quick. If we just go to the command prompt, we can say ping 10.10.10, 20.1, and make sure that that ping is going across, and we can see yes, that is functioning. Let's see if we can ping to our other PC, and the answer is yes, we can. So the first one times out because all of your devices are trying to do the ARP requests and various things that they need to do to map that path. But once it's found the path, then it is able to ping, because the only device that's doing any routing is the router, and it is directly connected to each of those networks. All right, what is step 3? We're going to configure switch 1 for remote management. So let's open this up. We'll go to the CLI. And this one has already been configured somewhat, so you'll notice that when I hit enter, it's going to ask me for a password. And same thing with the enable secret. So those are just Cisco and class, just like they are for the other things. And now we need to create the interface. So on a router, you put the IP address directly on each interface. On a switch, they are not able to do that, right? So switches, we don't put an IP address on any specific interface. We do it for the entire device, and so that is going to be VLAN 1. So config T, we're going to go to interface VLAN 1, and that is where we put our IP address. So IP address for this is 10.10.10.2, 255.255.255.0, and then again no shut. All right, so now I should be able to ping to and from switch 1, but switch 1 is going to need a default gateway still. So I'm going to do, this may be a little tougher to find, so let's let our question mark and our tab autocomplete functions do some work for us on this one. I've been using them throughout, but this may, I'm going to make sure you understand exactly what's going on here. So if I just put in a question mark, then I get all of the possible things that could happen at that particular prompt. And there's nothing in this one on the interface about a default gateway. That's because default gateways are something for the entire device, not just a single interface on a switch. So let's exit out of the interface configuration mode and just in config mode. So now I could try it here. So if I just start typing in default and hit tab, nothing happens. If I hit question mark, it's going to say unrecognized command. Okay, so now I know I'm not in the right place. So let's just get rid of that and try a question mark and see what I get. So this shows all of the configure commands that are available to me, and you'll see in here that IP is one of those, global IP configuration commands. So default gateway is probably going to be in there, so I'm going to do IP, and I'm going to use question mark again. And here we can see that default gateway is the second option here. So now if I just type in default and hit tab, it will autocomplete to default gateway. What else does this command need? I'll use a question mark again, and you can see it just needs the IP address. This A.B.C.D means that it's looking for our 4-octet IPv4 address. Because this is switch 1, that means that it is going to be 10.10.10.1 is our gateway. And that should be it. That's all I need to configure for this and on the switch. So now I'm going to do a copy run start here as well. Oh, but it doesn't like it in config mode. So copy run start. Startup config is the name. And now you can see that my completion percentage is 60 out of 60. So I've done all of the commands here to configure everything. So I would encourage you right now to stop the video and go through part 2 of the packet tracer. You're going to ask you to gather information and show using the show interface, show IP route commands. That way, as you go through those, you'll have a chance to see what they do, find that information, figure out exactly what's going on with each of those. Once you've gone through all that, then pick this video back up and we will do step 3. I'll do step 3 on the video and we can work through it. So for step 3, we're going to look at what happens to IP routing when we shut down one of our interfaces. So here we can see that we can ping from PC1 to PC2. So that ping is working both ways. And actually, let me see, can I do a -T? Nope, it does not like that. So the ping is working both ways, and what we're going to do is see what happens to our IP route commands and the routing table when we disable one of those. So on the router, on RTA, the first thing I'm going to do is do a show IP route. And we can see that we have 4 things listed in our routing table. 2 are networks, 10.10.10.0.24/24 and 10.10.20.0/24. And then we have 2 others that are listed with L, and these are the interface addresses, 10.10.10.1/32 and 10.10.21/32. So the C means that it is a network that is directly connected. L means that it is a local interface, and you can see that up here in the table as well. They give you codes for each letter you might see there. So now we're going to shut down gig 00 and see what happens to that table. So I'm going to go into config mode and interface gig00. And remember the command we used to open this up was no shut. So now we're going to enter the shut command. And you see immediately that we get a status message here and our link lights change. If we go back to S1, we'll see that we get a status message here as well saying that those have been shut down. So now let's take a look at our routing table. So and show IP route. And you'll see that we only have one network and one interface listed there. So if you're trying to do troubleshooting and you expect a network to be connected, but you're not seeing it in the routing table, then that lets you know that we've got that network is down. We've misconfigured something and we have to figure out what. Also notice that they want us to do a show IP interface brief. And when we look at this, then that tells us what state our interfaces are in. So when we look at gig 00, which we just shut down, we see that the status is administratively down. That is the message that we see when you have issued the shutdown command. When you first set up a router before you do any configuration, all of the interfaces are in that administratively down status. But as we bring them up, as we issue that no shut, then they go to up. And if we see the administratively down in our interface table, then that lets us know that it is shut down. If that command said it was just down, then we need to either check our cabling or maybe there's some other configuration issues that we need to check out. To fix this problem, all we need to do is enter the no shut command on that interface, and we'll see that things come back up. Before we do that, let's just double check. When we ping from PC1 to PC2, we're going to see that it fails. And all of my other configuration is still there. It still has the link. It still has the IP address. I just need to do a no shut command. And immediately you see the link lines change. You'll see that the line protocol has changed state to up. And then switch 1 has also the same message that changed state to up. And so that is how you do a little bit of troubleshooting with this. And also a pretty good description of what we do to configure routers and switches and how you work through a little bit of troubleshooting. Now that both of our link lights have turned green, that should mean that our pings will succeed now. So let's do ping that same way. And we see that we get successful pings after the first one. So that lets us know we have successfully completed this entire packet tracer.